All of my research focuses on one central theme, and that is the development of chemical and surface analytical tools for controlling the architecture of molecules and materials on the 1 to 100 nanometer length scale. The interesting chemical discovery here that led to all of these inventions is that if you take a nanoparticle made of gold and you synthesize DNA strands that have groups that can be tacked onto the surface of the particle, you can arrange DNA into a new format, into a spherical form. And we call those spherical nucleic acids. So think of a shell of DNA on the surface of a tiny little particle. We've seen just explosive growth in the interest of these types of particles. And it turns out when you arrange DNA in this format, you get an interesting property where these types of structures will go through cells, human cells in fact, enter them freely, whereas linear DNA won't. Why is that important? Well, once you can get these types of structures inside cells, you now can begin to flip genetic switches and begin to regulate things called gene expression. And that allows you to take, for example, a disease cell and correct what makes it a disease cell. So in the case of a cancer cell, you can flip genetic switches that cause those cells to selectively die. In the case of other cells, you can up and down regulate the expression of certain types of proteins to take them from the unhealthy state into the healthy state. And the other thing that we've invented with a lot of these nanoparticle-based detection schemes and also these spherical nucleic acid architectures are high-sensitivity protein-based assays. And these allow you then to begin to look at markers for disease at much earlier time points. It gives you a different radar. So PSA is an interesting marker used for routine screening for prostate cancer. Every man above the age of 40 will likely have a PSA test in the developed world. I believe that not just one, but many of our technologies will lead to very viable treatments for many forms of cancer, and hopefully, in certain cases, cures for different types of cancers. And I think what we're seeing is a whole new platform emerging that is going to provide a route to really enabling nucleic acid-based therapeutics in a way that we dreamed about a decade ago, but are just beginning to realize today.